So let's go ahead and go over these. Alright, the first one is actually involving what we call proportions, which we're about to talk about, but a proportion involves ratios, so it kind of fits with ratios too. And if you'll notice that in this ratio, x is on top and y is on bottom. And in this ratio, x is on top again, but now k is on bottom. And we're trying to compare k and y at the bottoms. If you will pick something for x and y, right? What can I pick for x and y so that x over y will equal 4/3?
16 over 12.
16 over 12, 8 over 6, 4 over 3. You could pick 4 and 3. Doesn't matter. I heard 16 over 12 first, so I'll use 16 and 12. If x is 16 and y is 12, that would reduce to 4/3. So now when I come over here, x still has to be 16, so what does k have to be? In order for this to reduce to 1/2.
32.
Y, k, I'm sorry, not y. K would have to be 32. So that 16 over 32 would be 1/2. So once you figure out what k would have to be, if x stays the same in both of these ratios, now you can say, well, k over y, 32 over 12, and then you could divide both of those by 4, would be 8 over 3.
I told you.
So this is a good one to plug in on, right? You just have to be careful about what you plug in. You have to pick an x and a y so that when you make a fraction out of them, it reduces to 4/3. And whatever you pick for x in this fraction, it has to stay the same in the second one, and that's going to dictate what k has to be. Then once you do that, you can make a ratio of k over y and reduce that ratio to get 8/3. Okay. Number 16. The junior class at Moreland High is composed of boys and girls in a ratio of 5:1. All the following could be the number of students in the junior class except which one? Okay, so remember, if we were going to figure out how many boys and girls were actually in the junior class, the first thing we would do would be we would add these together. And then we would divide that number into the total number of students. So basically this is asking you which of these is not a multiple of 6. That's all this question is asking you. So which one will 6 not go into?
E.
E. Yeah. Did y'all get that?
Yeah.
Yes.
Good.
That's the only one I got though.
That's good. See, I thought that was harder than 12. Well, good. Okay.
I put 2/3.
40 gallons of a certain mixture is made up of 3 parts water and 5 parts liquid X. So this is telling you the ratio of water to liquid X. The ratio is 3 to 5. If the mixture must be changed in order to be 75% liquid X, how many gallons of liquid X must be added to the original mixture? Okay. So what we have here is right now, what percent of the mixture right now is liquid X? Well, it's 5 out of 8, right? If you add those together. Right now, it's 5 out of 8 times 100, which would be 62.5% liquid X. Okay. Alright, so let's say that we have 8 gallons of this mixture. 3 gallons of water, 5 gallons of liquid X. We want to figure out how many gallons we have to add to the original mixture to turn this into 75%. Alright, so let's just start with answer choice C. Let's plug in. Let's say we added 35 gallons. Oh, okay, this starts with 40 gallons, right? I was like, how are we going to work this? We don't have the right information. Okay, so we start with 40 gallons of this mixture, which means that we're starting off with how much of each one? If the ratio is 3 to 5,
So 15.
we add those together, that's 8, right? And divide into 40. This is 15 and 25, right? Right now we have 15 gallons of water and 25 gallons of liquid X. Remember the steps for figuring out the actual amounts. You add these together, 3 plus 5 is 8, and then you divide the total by that number. So we do 3 times 5 and 5 times 5. That tells us how much we actually have of each one. All right, so let's say we're going to add 35 gallons of liquid X. If I add 35 gallons of liquid X, I'm still going to have 15 gallons of water, but now I'm going to have 60 gallons of liquid X. All right, if I add 35. So now, what's the percent that's liquid X? Well, it's 60 out of 75, because now the total that I have is 75, times 100, which is 80%. So I added too much. I've increased the percent of liquid X from 62.5% to 80%. So adding 35 was adding too much. It made the percent of liquid X too high. So it's not C, D, or E. Alright, so it's not this one where we added 35. Alright, that doesn't work. So what if we add 20? Then we would have 15 gallons of water and 45 gallons of liquid X, right? Because we're adding 20 to the liquid X. So we have 45 out of 60. 45 out of 60 times 100. 75%. I messed that one up to start with because the word 40, I was looking for a number. So the answer here is D. You would add 20 gallons of liquid X to make it a total now of 60 gallons of the mixture. Because you started with 40 gallons. If you add 20 gallons of liquid X, you've got a total of 60 gallons. 45 of those gallons are now just pure liquid X, and 45 out of 60 times 100 is 75%. So that tells you what percent is liquid X. And that's what we were trying to change it to. There's a reason that one was hard. Several reasons that one was hard.
That was really hard.
Yes. Okay. Let's see if we can do one more topic today. Proportions. Alright, to set up a proportion, match your categories on top and bottom. That's really important. That when you set up a proportion, you set it up so that you have the same thing on top in both of your ratios, the same thing on bottom. A proportion is just a statement that two ratios or two fractions are equal. So for example, if 10 nails cost 4 cents, how much do 50 nails cost? So be sure that you set it up either nails over cents or cents over nails, but you are consistent. Right? I can either say 10 nails cost 4 cents, so 50 nails cost what? Or I can say 10 nails cost 4 cents, so 50 nails cost what? But I need to know, do I have nails on top or cents on top? Which one do I have? Okay, either way that you work this out to solve it, you cross multiply and then divide. So we would get 10 times x. On both of these, you get 10 times x, which is 10x, equals 50 times 4, which is 200. Either way you look at it. So on both of these, you get 20. Doesn't matter which way you choose to do it, just be consistent. Okay, so 20 cents, that's how much 50 nails would cost. 5 times as much because it's 5 times as many nails. Make sure your answer makes sense. It's rare that you'll see an inverse variation problem, but they could ask you an inverse variation problem. It is something that you learn in Algebra 2. To solve an inverse variation problem, you use the following setup. If two things vary inversely, inverse variation means that you're going to multiply those things together. Direct variation means you divide. So just remember, direct divide. Inverse variation, you multiply. It's kind of confusing because when you think inverse, you think a fraction, you think you should divide, but you don't. So, for example, if the value of x is inversely proportional to the value of y, what that means is that if x increases, y goes down. If x goes down, then y goes up. They vary inversely. Whatever one does, the other does the opposite. So, if y is 4 when x is 15, what's the value of x when y is 12? This is kind of like a proportion, but you don't divide, you multiply. So, what this says is that when y is 4, x is 15. So this is y, this is x. What's the value of x when y is 12? So when y is 12, what's x? Right. X would have to be 5. So basically when you multiply the first y and x together, you get 60. That's what the second y and x have to equal when you multiply them together. Whenever the y goes up, right, the y got multiplied by 3, the x has to go down a proportional amount to keep that relationship balanced. So if I multiply y by 3, I have to divide x by 3. If you work this out, you end up with 4 times 15, which is 60. 12 times x, 12x. You divide by 12, you get the x is 5. Again, inverse proportion, not common to see on the SAT, but if they asked about it, it's an easy problem if you remember what inverse variation means. It means that they have to multiply together to give a constant amount. It's kind of like a proportion, but not a fraction proportion. All right. Let's see. To solve a rate problem, set up a proportion. So if they tell you the rate that someone is doing something and then they ask you to figure out a certain amount of time if they continued at that rate, you're going to set up a proportion. So Bonzo rode his unicycle 30 miles in 5 hours. So I'm putting miles on top, hours on bottom. How long, so they're asking me for hours, would it take him to ride 12 miles at the same rate? So you set up a proportion. Miles over hours equals miles over hours. Cross multiply. 30x equals 60. 60 divided by 30. It's going to take him 2 hours to ride 12 miles. If it takes him 5 hours to ride 30. Alright, so this will be the last thing we do today. We'll do the proportions quick quiz, which is quick quiz number 8, I think. Isn't that what we're on? Yeah, quick quiz number 8. And we do have one easy, one medium, one hard, so you do see that they can't be easy. Can't see an easy rate problem. Alright, so take about 5 minutes to work those 3 in.